Hello everyone, welcome to new class. Today's class is about the problems on AC circuits. This is this third part, and if you didn't watch the first two parts, please go through it. The link will be given in the description box. So let us go through the problems. And these are very important problems in the AC circuits. First problem, an alternating voltage 160 plus J120 volt is applied to a circuit and the current in the circuit is found to be 6 plus J8 ampere. Find the impedance of the circuit, the phase angle and the power consumed. That is, this is in the form of A plus JB format. So, we have to find the impedance, phase angle and the power consumed. The given data are voltage V is equal to 160 plus J120 volt, current is equal to 6 plus J8 ampere. And impedance Z is equal to V by I, that is 160 plus J120 divided by 6 plus J8. And here multiply the denominator and numerator with the conjugate of denominator. That is 160 plus J120 into 6 minus J8 divided by 6 plus J8 into 6 minus J8. That is 160 into 6 is 960 minus 160 into minus J8 is minus J 1280 plus J120 into 6 is J720 plus J120 into minus J8 is 960 divided by, this is in the form of A plus B into A minus B and is equal to A square minus B square. And here we get 36 plus 64, that is 1920 minus J 560 divided by 100 and is equal to 19.2 minus J 5.6 ohms. And here we can convert this rectangular form into polar form using the scientific calculator and then divide in polar form. Both this numerator and denominator you have to convert to polar form, and in that case we can easily divide the numerator and denominator because that is in the polar form. So the magnitude of Z is equal to square root of real part square plus imaginary part square and is equal to 20 ohm. And phase angle is cos inverse of R by Z. That is cos inverse of resistance is 19.2 divided by Z is 20 and we get 16.26 degree. And also the magnitude of voltage is, because the voltage and current are given in the rectangular form, so we have to find the magnitude of voltage and current in order to find the power consumed. So magnitude of voltage is square root of real part square plus imaginary part square and we get 200 volt, and the magnitude of current is equal to square root of 6 square plus 8 square and is equal to 10 ampere. Here also you can convert the voltage and current into polar form. That is, the rectangular form is 160 plus J120 and that you can convert to polar form using the scientific calculator. Then we get the magnitude. So the power consumed is Vi cos phi, that is 200 into 10 into cos 16.26, that is equal to 1920 watts. And here the phase angle is leading because the impedance we got as Z is equal to 19.2 minus J 5.6. So here this is a capacitive reactance of minus J 5.6 ohm. So the phase angle is leading. Let us go through another problem. A 50 Hz sinusoidal voltage 40 plus J30 volt is applied to a series RL circuit resulting in sinusoidal current 4 plus J1 ampere. Calculate the impedance of the circuit, power consumed in the circuit, and the power factor of the circuit. Here the voltage given is 40 plus J30 volt, and that we have to convert to polar form using the calculator. And I have already explained how we can convert the rectangular form into polar form using a scientific calculator. If you didn't watch it, please go through it. So the rectangular form 40 plus J30 is converted into polar form and is equal to 50 angle 36.9 degree. Similarly, current I is equal to 4 plus J1 and is equivalent to 4.123 angle 14 degree. Now the impedance Z is equal to V by I, that is equal to 50 angle 36.9 divided by 4.123 angle 14 degree. And we are converting this rectangular form into polar form to make our calculations very easy. That is, here we can divide this numerator and denominator very easily. If it is in the rectangular form, we cannot divide it. Either you can go through the conjugate method, or using the scientific calculator we can do the problem very easily. So we get Z is equal to 12.13 angle 22.9 degree, and it is equal to 11.17 plus J 4.72 ohm in rectangular form. That is, from this rectangular form of impedance we get a resistance R is equal to 11.17 ohm and XL is equal to 4.72 ohm, because it is already given that it is an RL circuit. The power consumed equal to I square R, that is equal to 4.123 square into 11.17 equal to 189.88 watts. Or we can use the equation Vi cos phi. Vi cos phi. And in that case we have to find the value of power factor. That is, power factor cos phi is equal to cos of the angle 22.9 equal to 0.921, or we can do in another way, that is R by Z. Cos phi is equal to R by Z. R is 11.17 divided by the magnitude of Z we have to taken here, that is 12.13 and is equal to 0.921. Let us do another problem. A 230 volt 50 Hz supply is applied to a coil of resistance R is equal to 10 ohm and inductance 0.2 Henry, calculate the reactance and impedance of the coil, current and its phase angle relative to applied voltage. The given data are resistance equal to 10 ohm, inductance 0.2 Henry, frequency 50 Hz. From that we can find reactance XL equal to 2 pi FL, that is 2 into 3.14 into 50 into 0.2, that is equal to 62.8 ohm. And from that we get the impedance, that is impedance is equal to square root of R square plus XL square and is equal to square root of 10 square plus 62.8 square equal to 63.6 ohm. So the current I is equal to V by Z, that is equal to 230 divided by 63.6, that is equal to 3.61 ampere. And the power factor cos phi is equal to R by Z, that is equal to 10 divided by the magnitude of Z, that is 63.6 equal to 0.157. And the phase angle is cos inverse of 0.157, that is equal to 80.9 degree. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.